This video is a general overview of what we mean by a reaction mechanism in A-level chemistry and what the general rules are for drawing them. We won't go into the specifics of addition, substitution or elimination in this video, but we will talk about what the general conventions are. The AQA specification says that reaction mechanisms can be used in order to explain the reactions of organic compounds, and the way that they do this is that they show us where the electrons are moving using arrows, and this allows us to see which bonds are being broken in the original reactants and then which bonds are being formed, and it can show us all the intermediate steps if we're looking at more complicated reactions. You might have already seen some of these curly arrow diagrams, and they can look a little bit intimidating and a little bit complicated, but the good news is that actually the diagram is quite straightforward because it has some rules that are really consistent across all of them. So really you just need to remember what the mechanism is, and then the diagram is easy to draw. So the first thing that you need to know is that these arrows represent the movement of electrons. And you'll notice that both of the arrows in this diagram have a full double head, and that shows me that two electrons are moving. So both of the electrons in a bond or both of the electrons in a lone pair. And you might be thinking, well, is it possible for just one electron to move? And it is. So here is a chlorine molecule. And if that chlorine molecule is exposed to UV light, it can undergo something called homolytic fission or radical fission. And what happens there is that one of the electrons in the covalent bond goes to one atom and one of them goes to the other atom. And that's how we form something called chlorine radicals. So a radical is a species, that means an atom or a molecule, that has a single unpaired electron, and it makes it really super reactive. Now, actually, for AQA, we don't worry about these single-headed arrows. You don't need to be able to do this for the formation of radicals, but you do need to be able to recognise that this symbol, the Cl, with the single dot, that shows a radical. And it's not just chlorine that forms radicals, but they are one of the first radicals that we will meet in year 12. Anyway, back to this other mechanism that we were looking at. You'll also see that each one of the arrows starts from a pair of electrons. So we've got the double dots on the hydroxide. That shows me that's what we call a lone pair. So a pair of electrons that aren't involved in a bond. So I've got one arrow that goes from that lone pair, and the other arrow that I've drawn goes from the covalent bond between the carbon and the chlorine. So again, that's an electron pair. So whatever the arrow is that you're drawing, it's always going to be starting from a pair of electrons. It's not going to start from an atom. That's a really common mistake that we see people making. Then in terms of where the arrow ends up, we've got two options. Either we're forming a new bond. So this hydroxide here is going to come in and it's going to form a bond with that carbon. So that first arrow is finishing up with the carbon. Or we're going to end up forming a new species that has a lone pair. So with my second arrow, both of the electrons that are in that carbon to chlorine covalent bond are ending up with the chlorine. It's also worth noting that some exam questions will just ask you to draw the mechanism, whereas some will specifically say you need to show the organic product, which is this one here that actually contains carbon in it. Personally, I tend to just draw the full mechanism with the product, whether it's asked for or not, and that way you're always covered. Thanks very much for watching, and I hope you found this video useful in your A-level chemistry studies. If you did find it useful, then don't forget to like and subscribe for more A-level chemistry videos coming soon.